Today we will see how to integrate sine nth power x dx without using the reduction formula. That means we will see how to integrate sine nth power x dx without using any integrations by parts. For this method, you have to pay attention first on the value of n, whether your n is an odd number or whether it is an even number. Depending on whether it is odd or even, there is a unique approach for each case. During the discussion today, I'm going to look at the case where n is odd. There will be a separate video explaining the case where n is even. Alright, let's say your n right here is an odd number, such as 3, 5, 7, 9, and so on. Now, in that case, integration sine nth power x dx, we are going to write it as integration sine n minus first power x times sine x dx. When n right here is an odd number, n minus 1 should be an even number. Therefore, sine raised to the n minus first power x can be written as a function of sine squared x, such as sine squared x raised to some kth power where k is a positive integer. After that, what we do is we are going to replace this sine squared x term by 1 minus cosine squared x, and all of that will happen to be raised to the power k. And then what we do is we will write down the expansion of 1 minus cosine squared x raised to the kth power. And each term inside that expansion will be some cosine squared x term. And each of those terms will be multiplied by the sine x term right here. And then we can easily integrate it using the theorem that we discussed earlier, which was integration f of x raised to the nth power times f prime x dx. We know this is going to be equal to f of x raised to the n plus first power over n plus 1. This theorem holds true for all the cases where n is not equal to negative 1. We know cosine x, if differentiated, the answer is equal to negative sine x. For that thing, what we don't have right here with the sine x term is only a negative symbol. But we can easily create a negative symbol for the sine x term by writing another negative symbol outside the integral sign. Alright, that's all about it. Now we will do an example. We will evaluate the integral sine 7th power x dx. As per the instruction given, we need to write it down as integration sine 6th power x times sine x dx. So this is equal to integration sine squared x raised to the 3rd power times sine x dx. So in terms of the language used earlier, our k is equal to 3. The next step is to write down this sine squared x term using 1 minus cosine squared x. That is because according to the Pythagorean identity, we know that sine squared x plus cosine squared x is equal to 1. Therefore, sine squared x is equal to 1 minus cosine squared x. I'm going to use that relationship right here, integration 1 minus cosine squared x raised to the 3rd power times sine x dx. The next task is to expand 1 minus cosine squared x to the 3rd power. We can do it easily if we remember how to expand a minus b to the 3rd power. If you expand a minus b to the 3rd power, the terms will be a cubed minus 3a squared b plus 3ab squared minus b cubed. We can use that expansion with a equals 1 and b equals cosine squared x in order to expand 1 minus cosine squared x to the 3rd power. Alright, let's use that and expand it. We have integration within parentheses 1 raised to the 3rd power is equal to 1 minus 3 times 1 raised to the second power times cosine squared x plus 3 times 1 times cosine squared x raised to the second power, which is cosine fourth power x, minus cosine squared x raised to the third power, which is cosine sixth power x, and outside I have a sine x dx. Now I can distribute this sine x term to each of the terms inside the parenthesis right here and write down those as separate integrals. The first one will become integration 1 times sine x is just sine x dx. The next one minus, there's a 3 right here, which I'm going to write outside integration cosine squared x times sine x dx, and the next one is plus. There's another 3 right here, which will also be written outside 3 integral cosine fourth power x sine x dx, minus the last term right here, integration cosine sixth power x times sine x dx. Of course, we can quite easily integrate the first one. To integrate the rest, we are going to use the theorem integral f of x raised to the nth power times f prime x dx is equal to f of x raised to the n plus first power over n plus 1. To use that theorem with f of x being equal to cosine x and n in the first integral right here equals 2, in this integral right here n equals 4, in this integral right here n equals 6. We can do it as that provided we have negative sine x in these 3 places, because cosine x differentiation is equal to negative sine x. So I'm going to create negative symbol by putting another negative symbol outside the integral sign. So I'm going to change this to a negative sine x in that integral. I will need another negative symbol outside, which will make this one a positive sign. Right here also I'm going to make this term a negative term. That means this positive symbol right here should become a negative symbol. So I'm going to go ahead and erase that positive symbol, and I'm going to write a negative symbol outside. With the last integral right here, once again I need this to be a negative sine x. I will need another negative symbol outside, which will make this one a positive. Alright, now we have everything necessary. We can write down the final answer in one shot. Equals, the first integral is to integrate sine x. Integration of sine x is equal to negative cosine x. The next one is, I have a 3 right here plus 3 times integral cosine squared x times negative sine x. It will be equal to cosine third power x over 3. And then I have a negative 3 right here outside. So let me write down that negative 3, and then I need to integrate cosine fourth power x times negative sine x dx, which will be equal to cosine fifth power x over 5. And then we have a plus sign right here, plus this integral cosine sixth x times negative sine x dx. It will be integrated as cosine 7th power x over 7, and of course there will be a plus c. We can simplify this one a little bit more. These 3's can be cancelled, and that's it. This is going to be our final answer for the integration of sine 7th power x dx. This answer is really more efficient than the answer that we obtained using the reduction formula. Alright, now if you would like to practice this method, here's a homework question for you. Integrate sine 9th power x dx. Now this 9 right here, the exponent is an odd number, therefore the method that we discussed in this video can be directly applied. When you do that, you will have to expand 1 minus cosine squared x raised to the fourth power. It will be easy if you remember how to expand a minus b raised to the fourth power. What are the coefficients of that? To determine the coefficients of a minus b to the fourth power, we can look at the Pascal's triangle. We have ones on the first column and another one right here, and then we need to add these two numbers and write down the summation here as a 2, and then we have a 1, and then we are going to add these two numbers and write it down here. 2 plus 1 is a 3, and then we are going to add these two numbers and write it down right here, and 2 plus 1 is once again equal to 3, and then we have a 1. And similarly, we are going to add these two numbers and write it here. 3 plus 1 is equal to 4, and then we are going to add these two numbers and write it here. 3 plus 3 is equal to 6, and then we are going to add these two numbers and write the answer here. 3 plus 1 is equal to 4, and there will be a 1 again. And these are the coefficients corresponding to each of those powers: 0, first power, second power, third power, and the fourth power. What we have right here is a fourth power. Therefore, what we need is this line as the coefficients. Therefore, when you expand a minus b to the fourth power, your terms will be a to the fourth minus 4 a cubed b plus 6 a squared b squared minus 4 a b cubed plus b raised to the fourth power. Alright, now you can try this question with that small help. I hope you will get the correct answer. Thank you so much for watching this video. Have a nice day.